Simply supported beam subjected to point load. Now we'll be seeing how to find out the reactions of simply supported beam subjected to a point load. So first we'll write a question. A simply supported beam subjected to point load of 10 kilonewton at center. Span of simply supported beam is 10 meter. Okay, so this is the question. So based on the question, we'll try to draw the diagram first. This is the beam. To make it simply supported, we'll add here one support. This is hinge support, and the another support is roller support. Now this is a simply supported beam. Now what is the length of the beam or the span of the beam? The span of the beam is 10 meter. So this distance is 10 meter. Now it is subjected to point load of 10 kilonewton at center. Means at a distance of 5 meter from any side, there is one load which is present, and the value of this load is, what is the value? Value is 10 kilonewton. So pay attention. You need to see which kind of load it is. Okay, we have seen four types of loads. One is point load, then UDL, UVL, and combination. Okay, so if a point load is given, then you have to draw the point load. If in question UDL is given, you have to draw the UDL. So here we'll apply a point load of 10 kilo Newton at the center. So as it is at the center, that means this distance will be 5 meter and the remaining distance will also be 5 meter. Now this is the question. Okay, this is given in question. First thing that we have to draw is, we have to draw the reaction diagram for this. The reaction diagram for simply supported beam. So drawing the reaction diagram means we have to remove these two supports. You have to remove these supports. So same thing we will do. This is the beam. If we remove this hinge support, how many reactions will come? Two reactions. If we remove this roller support, there will be one reaction. So these are the three reactions now for simply supported beam. We'll give the names also. Point A, point B. This is A and B. So this will be VA, VB, and this is HA. Now other than this, what is the load which is present? We have to draw same. What is the load? The load is 10 kilonewton and it is present at the center. So this is 5 meter, 5 meter, and total is 10. Now this second diagram is called as the reaction diagram. Now in this reaction diagram, okay, in this reaction diagram, we have to apply our first superpower. What is the superpower that we have? Condition of equilibrium. So we have to apply the conditions of equilibrium in this reaction diagram. So applying conditions of equilibrium. Applying conditions of equilibrium. So what is the first condition? Sigma fx is equal to 0. Sigma fx is equal to 0. Now there is only one force which is acting in horizontal direction. Okay, that is HA. So this is HA and this is equal to 0. So we have got the first answer, that is the value of HA. This is 0. Second condition, sigma Fy is equal to 0. Sigma Fy is equal to 0. Now how many forces are acting in vertical direction? This is the horizontal direction and this is the vertical direction. Positive Y and downside negative Y. How many forces are acting? So 1, 2 and 3. So we'll write it according to their signs. So VA minus 10 plus VB is equal to 0. So if we write it properly, it will be VA plus VB minus 10. If it goes to the right hand side, it will be plus 10. So VA plus VB is equal to 10. So this is the second condition. Now, but from here we cannot find out the value of VA and VB. So we will have to use the third condition, that is sigma m is equal to 0. Now this sigma m means summation of all the moments of forces about any point that is equal to 0. So we'll take point A, moment about point A. So about this point we will take. Now the formula for movement is force into distance. Okay, force into distance. Okay, now we will find out the movement of all the four forces. What is the movement of force HA about point A? Same formula will apply. It will be force into HA into distance. What is the distance between HA and point A? It is 0 because the force is passing through point A only. So it is 0. Now the second one is VA. So we'll write VA multiplied by, what is the distance between VA and A? This is also 0 because it is passing through A. So 0. Third force 10. So we'll write here the moment of 10. What is the moment of 10 about point A? Force into distance. Now the distance between this 10 and A is 5. So this is 10 into 5. And the last one is VB. What is the moment of VB? Same formula, force into distance. So VB, force multiplied by distance. This total distance is 10. Now we have to give the signs. Now as these first two terms are 0, no need to see for the signs. Okay. Now we will assume one direction of the sign, that is we will assume all the clockwise directions are positive. All the clockwise directions are positive. Now how to identify that the movement of 10 kilonewton is clockwise or anti-clockwise? So for this you just fix this point A and see how the beam is rotating. Remove everything, just put your finger on point A and see how the beam is rotating. So if you see, this force is taking the beam in downward direction. So the beam will rotate in this direction. And if you look carefully, this direction is nothing but the clockwise direction. As it is clockwise, we'll take it as positive. So this is plus 10 into 5. Now the last one is VB. Now how the VB is rotating the beam? Remove all the other forces. Remove HA, VA and 10. Excuse me. Remove all HA, VA and 10 and see how the beam is rotating due to VB. So you can see the VB is taking the beam in upward direction towards point A. Now this rotation if you see, this is in anti-clockwise direction, opposite to the direction of clockwise. Okay, so this is an anti-clockwise direction. If you are taking clockwise positive, then anti-clockwise will be negative. So this total will be equal to 0. Now let's write it once again. 10 into 5 is 50. 10 into 5 is 50 and 10 into VB is minus 10 VB. This is equal to 0. So 10 VB is equal to 50 and VB is equal to 50 divided by 10, that is 5. So now we have got the value of VB as 5. But we have one equation here, VA plus VB is equal to 10. So we'll substitute here, VA plus VB is equal to 10. That means VB value is 5 is equal to 10. So VA is equal to 5. So with this now we have found out all the three reactions, that is HA, VA and VB. Now we will write this so that we can understand it properly. So this is our beam. So our beam is subjected to one external load of 10 kilonewton. Due to this, there are three reactions which are produced. This is point A, this is point B, this is HA reaction, VA and VB. The value of VA is 5, the value of VB is also 5 kilonewton, and the value of HA is 0. Okay, the distance here is 5 meter and this is 5 meter. Total distance is 10 meter. This is how we can find out the reactions of simply supported beam. Okay, so in the next class we'll see one more problem of simply supported beam subjected to point load. For now, you just see it once again how to apply these three conditions. You have to see this sigma ma properly. Okay, this is an important condition. These two are very easy condition, but the only problem you will get in this third condition. Okay, so properly decide one direction, that is clockwise direction positive and anti-clockwise negative. Then apply the moment formula, that is moment is equal to force into distance, and then you can find out the reactions of the beam. So once again we'll see how to solve or how to find out the reactions. First draw the reaction diagram of the given beam, then apply the conditions of equilibrium.